Okay guys, so our objective for today is being able to balance unbalanced equations. So what we're going to be working on is looking first to see if an equation is unbalanced and then figuring out how to rebalance it. So what I want you to do first is with your partner, I want you to look at figure 1 and figure 2, figure out if they are balanced or if they are unbalanced. And then I want you to figure out what could you do to make them balanced. So if you figure out that they're unbalanced, what could you do to make them balanced? So let's take 3 minutes, come back together at 9 o'clock. With your neighbor, I should hear you talking. What could you do to make these balanced if they are unbalanced?
It's unbalanced because it's not equal on both sides, so it's uneven. So we can either add 2 more hydrogens or take an oxygen away because
Good. I hear people saying that these are unbalanced, and now you need to figure out what could you do to make them balanced.
But I said we could add 2 more hydrogens or take an oxygen away.
Good. So how are y'all figuring out that you could rebalance them?
By adding the groups and adding and taking away to make them even.
Okay, so you could either add or take away. Good. Okay. Excellent. Once you've figured out what you need to do for figure 1, do it for figure 2. It is 8:59. We have 1 more minute to figure out how to get these rebalanced.
Okay, for this one, we could add 1 more hydrogen to make it even, or it's the same. We could either add 1 more hydrogen or take an oxygen away, so only be 1, but you need 2. So we have to add 1 more hydrogen to this
By about 30 seconds. Okay, 20 more seconds. If you haven't figured out how these are balanced or unbalanced and how to fix them, do that now. Okay, it is 9 o'clock. Voices need to be turned off, and let's double check and see if we got these correct. So, on figure number 1, Yandel, is that balanced or unbalanced?
Oh, yes. Well, me and my team worked on it and it was unbalanced.
Excellent. It is unbalanced. And how did you know, Takidra, that figure 1 was unbalanced?
Because one side was 4 and the other side was 3.
Good. So the number of atoms was not the same on both sides. Which side, the product side or the reactant side, had more atoms? Ariel? Good. The reactant side has more. So we need to figure out how to get those balanced. Figure 2, was that balanced or unbalanced? Let me hear from Jacqueline on that one. Balanced or unbalanced? Good. It is also unbalanced. And what is unbalanced about figure 2? Vanessa? Good. So on the reactant side, I'm seeing 4 hydrogens, but on the product side, I'm seeing 4 hydrogens, but on the reactant side, I'm seeing 2. And be really careful. Don't do what I just did and switch up your reactants and your products. One of the first things that I saw a couple of you do was go ahead and label them. So we always want to label this side with our R for reactants and this side with a P for products. If you haven't done that, fix that now. And go ahead and turn your paper over to the back of your first page. So I heard some of you guys having conversations about what you could do to make these balanced. Kayla, what did your group come up with?
We said that we could either take away a hydrogen for the first one to make it even for both sides, and then for the second one we said we could add a hydrogen or we could
Good. So I heard in all the groups that I heard having conversations about this, I heard I could either add or I could take away. And so what I want first for us to understand is that with all of these problems, we will never be taking away. We're always going to be adding. But I heard lots of good discussions, and we're going to see today how exactly we can balance them. Now, I want us to start off here with remembering what the law of conservation of mass says. What does the law of conservation of mass say? Turn and tell your neighbor. What does the law of conservation of mass say? What does the law of conservation of mass say?
That's why I'm here to
Yeah, no, what does the law of conservation of mass say?
mass can be greater.
Okay.
I do
Huh? Pin? Yeah, go check the drawer over there. Okay, let's bring it back together in 3, 2, and 1. So what does the law of conservation of mass say, Jocelyn? Good. Only change. And so that is why when we do these problems today, when we balance equations, we cannot destroy matter. So we cannot take away atoms. The only thing that we can do is add coefficients to get there to be more molecules of something. And you're going to see what I mean in a second. I want you next to, on your paper, where it says steps to balancing equations, I want you to put a star right there. Because that is your criteria for success today, and you're going to need to keep coming back to that when things get tough today. Okay, so good. I see Ophelia starring that. Everybody should be starring the steps to balancing equations. Okay, now, what I want you to do now is simply watch as I break one of these problems down step by step. And so you should have on your paper exactly what I have on mine to make sure that we are all doing this the exact same way. So the first thing that I need to do is follow step number 1, which step number 1 tells us that we need to determine if the equation is balanced or not. So I want you to look at the equation and figure out if it is balanced. Linda, you can use this one, sweetie. So is that equation balanced, Vanessa? Is that balanced? No. So off to the side, I want everybody to write a U and an N to stand for this is an unbalanced equation and I need to balance it. That's step 1. Step 2 is I need to pick out an element and rebalance it. So before I can do that, I've got to set up my T-chart. Everybody should be drawing that with me. And on my reactant side, I have hydrogen, I have oxygen. On my product side, I have hydrogen, I have oxygen. So I'm starting off by listing every element that's present on both sides. It's going to be important later to put your elements in the same order. So like if you put H on top over here, you need to have H on top on your product side as well, and you'll see why here in a second. So I have 2 atoms of hydrogen. I know that because I have a subscript of 2. And I have 2 atoms of oxygen because it also has a subscript of 2. And I have 2 atoms of hydrogen on the product side and 1 atom of oxygen. Because when there is no subscript, that automatically just means 1. And so I want to start off by figuring out how to get 2 for these 2 for my oxygen to have the same number on both sides. So what could I multiply by on this side for it to match up what's on the reactant side?
1.
If I multiply by 1, I get 1 times 1, I'll get 1. I can multiply by 2. So I want everybody to say, okay, times 2. That means now I would have 2 atoms of oxygen. So because I multiplied, that means that's now a coefficient, right? And so I have to go up here and add the 2. Well, I realize when I do that, that's also going to affect my H's. So because it's a coefficient that's attached here as well, I need to also multiply this by 2. So now I have hydrogen is 2 times 2, which means that how many hydrogen atoms do I have? 4. So that now takes me to say, okay, well my oxygens are balanced now, but my hydrogens are not. What can I multiply by hydrogen to get it to equal 4? 2 as well. So I say, okay, times 2 equals 4. Because I multiplied, that's a coefficient that I need to add in front of that H. Why do I not also multiply the oxygen? It's already 2, and what else? Is that oxygen attached to that hydrogen on the reactant side? No, that plus sign means that those are separated from one another. So anytime there's a plus sign, it means that those atoms are separated, so you don't have to do anything there. So the last step is I go through and I make sure that these are balanced on both sides. So I say, okay, I have 4 hydrogens, 4 hydrogens. On my reactant side, I have 2 oxygens. On my product side, I have 2. So now I have balanced my equation. So I just leave this one blank, and I should have 2 blank 2. You cannot subtract. So why can you not take away atoms? Think about the law of conservation of mass. Why can I not just take away something? I can't destroy it, right? I can't destroy it. All I can do is just say, okay, I'm gonna get more molecules. I'm gonna add coefficients to get them rebalanced. What about where?
Yeah, what you put on the other side.
Nothing. You put nothing.
So you don't need to put another thing, so you just leave it blank.
Right, you just leave it blank. Let's try one more together. Let's do number 2 of the teacher model together, and it might start to make a little bit more sense. So we have blank Fe plus blank Cl2 yields blank Fe Cl3. Natalie Nodell, this is your warning.
Just talking to me.
So the first thing that we need to do is go through and list every element, right? We've got to set up our T-chart, see if these are balanced. So I set my T-chart up. I'm going to list my elements. I've got Fe, I have Cl. This is all on my reactant side. On my product side, I also have Fe and Cl. And now I need to see if my atoms on both sides are balanced or not. So I have 1 atom of Fe. How many atoms of chlorine do I have, Lyndon? 2. How many atoms of Fe do I have on this side? 1. And how many atoms of Cl? 3. So is this balanced? No. Automatically I can see, okay, I've got a 2 here, I've got a 3 here, that's not balanced. So the first thing that I want to do is I want to try to get these chlorines balanced. So what could I do to get there to be the same number of chlorines on both sides? What could I do? Lyndon?
I was gonna say do something different.
Yeah, what would you do?
Multiply the Fe like times 2, because on the reactive side there's 3, whatchamacallit, 3 atoms, but then on the product side there's 4. And so like if you multiply the Fe times 2, that's gonna get you 4.
So you would multiply this by 2?
No, the Fe by 2 on the product side. On the
But
reactive.
right now, I started off, these are balanced right now, right?
Oh, yeah.
I was somebody trying to get the whole thing back.
Okay, so but we have to make sure we have the same number of atoms on both sides. So that was a good idea, good thought, but we want to get the same number of atoms. What would you do, Kayla? Yeah,
Can you multiply by different numbers?
you can, if they're not attached, right? So what I would do first is I want to pick one element, right? I want to isolate and just zero in on one thing. So I'm going to start with the chlorines. I'm going to say, okay, I want there to be the same number of chlorines on both sides. So I'm going to pick the smallest number first to see if I can get that balance. So in this case, that would be multiplying by 2. So I'd say, okay, times 2. 3 times 2 is what? 6. And so if I add a coefficient of 2 up here, I also, because these are attached to each other, right? That's one molecule. I also have to multiply that times 2. So now I have 1 times 2 is 2. Because I've done that, I need to get these to be the same, right? What can I multiply by Fe to get that to also be 2? Times 2. What can I multiply need to add that coefficient to the front. What can I do to that chlorine to get it to be equal to 6 times 3? That now equals to 6. So I'm putting whatever I multiplied by, that's what I'm putting as the coefficient on top. I always want to go back and just double check and make sure they're now balanced. So I've got 2 and 2 and 6 and 6. So that way I can see, okay, yep, this is now a balanced equation. Okay. The reason why, going back, because I saw a lot of like blank looking faces, the reason why I multiplied by 2 to start is when it's like this and you have a 2 and a 3, you just want to multiply by the lowest number possible, okay, to get them to match up. I want you to turn your papers over, and we're going to do the practice with a partner. I want you to start off by doing practice problem number 1, and I want somebody at your group to take on ownership, whoever feels the most comfortable. Lead your group through how you would balance practice problem number 1, and we'll come back together in a minute and a half.
So this one is unbalanced because you see H3 and H2 on this side,
Yeah,
so
but
it's
usually we'll
unbalanced.
figure out if these are balanced or
Then we make
unbalanced.
a T-chart for our reactants and
Unbalanced, good.
our
If it's unbalanced.
products. Like that. And then we're going to pick 2 for the reactants on that side, and we're going to
You need
pick
to
2
balance.
for
Yep, there you
that.
go.
And then you're going to pick 3 on this side, and you're going to pick 1 for this side. So now, for this side, we could do for the product side, we could, for the end, we could do times 2. And that'll give us 2, so now that both of these are equal, you could pick the 2 up here. And then for this one, we could do times 3. And
Okay guys, really quickly, I have a quick misconception alert that I want to point out because I just saw every group do this. So if you'll turn off your conversations and put your eyes on the screen, because basically everybody made the same mistake. So when we're looking at that first problem, it's really important that you put these in order. And this is what I mean by that. So when you're looking at problem number 1, and you say, okay, I've made my T-chart, I have H, I have an N, you need to line up, and that might mean you're reordering stuff, right? You also want to put the H on top, so these are even, and you also want to put the N's on the same level, because that way when you go to balance, you're looking like a cross, and it's not going to confuse you. So how many hydrogen atoms do you have? 2. How many nitrogen atoms? 2. On the product side, how many hydrogens? 3. How many nitrogens? 1. And so if you do it like that, it's much easier to say, okay, whatever I'm doing to this side, I also need to do to the other side. So go back to problem number 1, now that it's set up like this, and see if you want to change anything to your first problem. We'll spend 1 more minute on that. Good. Whatever you multiply by, that's now your coefficient. So you want to add that to the line. Yep, if you're ready to go, you can go ahead and do number 2. Take about 10 more seconds, finish up those conversations, and then we'll check number 1. Okay, let's bring it back together in 3, 2, and 1. So let's take a look and see what our coefficients should be here. So whenever you're looking at this one, raise your hand if you decided to balance your H's first. Okay, 2 people did. Raise your hand if you decided to balance your N's first. Okay, the rest of us did. And it doesn't really matter, I'm just curious. You can kind of start wherever. You just want to just pick one at a time. So let's do our H's first because they're on top. And so what did you multiply by to get your H's to be the same? What did you multiply by, Lyndon?
So 2 times 3 is 6, and 3 times 2 is 6.
Good.
So we got our h's to 6.
Good, so you got your h's to 6. Because I multiplied, that is now my coefficient. So I have a coefficient of 3 there, and I have a coefficient here of 2. Now, whatever I do to this one, these are attached to each other, right? And because they're attached to each other, I have to do the same thing I did there to this one. So I've got to also multiply that by 2. And so now my ends are 2 and 2. So guess what? That equation is now balanced, right? Because I have 6, 6, 2, and 2. Okay. Go ahead, if you haven't already, go ahead and start on problem number 2. If you get done early, you can work your way to problem number 3. Okay. Problems number 2 and 3 right now. People are breezing through the second one. We'll quickly check this one, make sure you got it right. I've looked at everybody but one's table, and they set it up just like this. They said, okay, NA, 1, CL has a subscript of 2, NA, 1, and CL. What did you multiply by to get your CLs to be the same on both sides? Let me hear from Ophelio. So what did you multiply by this one to get that to be 2? 2, great. Okay, so I say times 2. Now I have 2 on this side and 2 on this side, but I've got to add the coefficient up here, right? And because I did it to this side, what do I also have to do to my NA, Natalie? Good, I have to also multiply it by 2. And when I do that, now I have 2 and I have 1 over here. So what do I have to do to Kedra to this NA to make it the same as that side? Excellent, good. So now I've got times 2. That equals 2, and let's just double check and make sure they're all balanced now. So 2, 2, 2, and 2, and now I have a balanced equation, 2 blank and 2. Raise your hand if you're also done with number 3. Okay, about half the class. The other half of the class that is not done, go ahead and finish up with number 3 now.
Oh.
Separate them by elements. Yep.
So it's C and H.
H. Don't forget, whatever you multiply by, that's your coefficient. It goes in a blank. Good. Okay, we are ready to check number 3.
Wait, I am not ready.
Okay, just kidding. Take about 10 more seconds.
I shall not pass.
Miss, you can start.
No, ain't no. No.
I was telling first period that these problems remind me of like when you're like trying to put your hair up in the morning or something, and you like put it up, and then you're like, oh, there's a mistake. I gotta put it back down. And then you put it back up again. Like it's like a lot of just like over and over again, double checking, right? Me too. When you're like, oh, there's a little crease right there. I gotta put it back down. There's a lot of like keep on trying at these to make sure that they match up. So let's just make sure we have this right. Okay, let's bring it back together. Voices off in 2 and 1. I need my C's. I've got my H's. I've got my BR. Why did I not separate that B and the R from each other, Lyndon?
Because the B is the capital and the R is local.
Good. Same. I want to put everything in the same order on the other side. I've got my C, I've got my H, I've got my BR. I have how many atoms of C? 1. How many atoms of H? 4. How many atoms of BR? 2. What about on the other side? I have how many atoms of C?
1.
How many atoms of H? 2. And how many of BR? 4. Okay. So first things first. I want to just go with, I can pick whichever element, but only pick one. Let's pick this BR. What can I do to make those BRs the same? Times 2. Good. So I say times 2. Now that equals to 4. Because I'm multiplied by 2, this is the step I see some of you missing. I've got, if I multiply by 2, that's my coefficient that I need to add now. So before you move on, go add that coefficient. Then, okay, now those are even. What about to these H's? What do I need to do to this H? Let me hear this time from Vanessa. Vanessa, what do I need to do to this H to get it to be even? Good, multiply by 2, that equals 4 now. And because I multiplied, I add it to my coefficient. And let's just double check, make sure you got these right. We got 1, 1, 4, 4, 4, and 4. And so now this problem is balanced. Okay.
I did a lot more stuff.
You did a lot more steps. It happens, right? That's what I'm talking about, that analogy of going back and forth with your hair. Okay, so if you'll turn your paper over to the independent practice, let's talk about how to work through these today. It's not as scary as it looks. Okay, so make sure you're paying attention so you hear what you have to do and what you don't have to do. You do not have to do every single one of these problems. What you have to do is this. You're going to have to get to 100 points. So you can do that a couple of different ways. Appetizers, they are worth 5 points. Entrees, they are worth 10 points. And desserts are worth 15. And I've kind of broken down some suggested combinations of how you could get to 100. So if you take like home cooking, for example, if you went with that combination, you would do 9 appetizers, 4 entrees, and 1 dessert. Or if you want to go the way of doing less problems, but they're a lot harder, you could go the 5-star restaurant route where you only do 3 appetizers, 4 entrees, and 3 desserts. So you do less problems, but they're a lot harder, right? That's why they're worth more points. So how many total points do you need to get equal to? 100. Some people, what they decided to do in first period is they did every single entree problem, which you could do, and that would give you 100 points. So that's another way that you could attack this. I would call that your, what's a restaurant where you, like a buffet where you just eat things that are all the same? Like a Golden Corral. That's the Golden Corral way, is to do all entrees.
What about Luby's?
Okay. Paper, yes. So you're gonna wanna use some scratch paper, or if you don't write, like really, really tiny. So go ahead and get started on that. I'll bring some around.